All right, here we go with lesson 6, symmetries of regular polygons. Ready, set, let's go. All right, what is the smallest fraction of a circle that the wagon wheel needs to turn in order to appear to be the very same as it does now? All right, so notice all of these angles are the same. So they're all the same degree measure. There are 8 regions. A full circle is 360 degrees. So if I take 360 and divide it by 8, that would give me 45. And that is the angle of rotation that will get that spoke to that spoke, that spoke to that spoke, and so on. And it'll appear to be the exact same shape. So 45 degrees. Notice this has 5 regions. So take 360, and they're equal. The key is that they are equal angle measures. That's important. And that's going to give me 72 degrees. So that means if I rotate this 72 degrees, it'll appear to be the exact same as it is now. Woo! I better put a mark where I'm going to start my count. I'm going to start it there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I'm going to take 360, divide it by 18, because all of these 18 angles are the same. So if I take a full circle and divide it by how many angles there are, that will get me what each angle measure is. So 20 degrees will get this to look exactly like it does now. All right, that wasn't bad. Let's move on. Okay, number of lines of symmetry. Okay, so symmetry means it looks the same on both sides, right? If you flip it over the line. There is a line of symmetry. So notice right there, if I flip it over there, it's the same. There is a line of symmetry. If I flip it over there, it's the same. And that is a line of symmetry. So from the vertice to the middle of, that one's a little off, to the middle of this side. All right? So there are 3 lines of symmetry in a triangle. Let's try the square. This diagonal is a line of symmetry. A diagonal is a vertice connected to a vertice. This other diagonal is also a line of symmetry. Remember, symmetry implies it's the same on both sides. So notice that is the same as that. So that's symmetry. There are 2 more lines of symmetry. If I go through the middle of the sides, the top and the bottom look the same. And if I go through the middle of this side, then the left and the right look the same. So there are 4 lines of symmetry. I see a pattern. And the pattern is the number of sides that the polygon has is equal to the number of lines of symmetry. And if I wanted to show that, I would then do this 5-sided polygon. And your 5-sided polygon is called a pentagon. And so if I show that line of symmetry, there's 1, same on both sides. There's 2. There's 3. There's 4. And there's 5. Notice how those lines of symmetry meet at the same point in the interior of the polygon, right? Look at that. Boom, boom. And if I wasn't so off on that, on this line right here, it would have gone there. Okay, so that is 5. 1, 2, 3, 4, 5. So 5 lines of symmetry. And so number of sides equals number of lines of symmetry. All right, let's go here. This is asking me to draw all the diagonals in each regular polygon. Okay, so a diagonal has to be from vertice to vertice and go through the interior. So from vertice to vertice would not be a diagonal because it doesn't go through the interior. Vertice to vertice, not a diagonal. So there are none. There are no diagonals in a triangle. Here is a diagonal. Vertice to vertice, boom, vertice to vertice. So there are 2. This is a diagonal. 1, 2, 3, 4. I think that's it. No, we got one more. So 1, 2, 3, 4, 5. Let's see, I gotta count them. 1, 2, 3, 4, 5. So there are 5. Okay, let's go here. 1, 2, 3. 1, 2, 3. Got that one already. Got that. Boom, 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 boom. Each one should have 3 coming out of it. Okay, so the lines of symmetry are going to be 9 on this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so there's 9. Okay, let's see if we can come up with a pattern. I think for an n, it's going to be n times n minus 3 divided by 2, where n is the number of side lengths the polygon has. So for example, if I have 7, it's going to be 7 times 7 minus 3 divided by 2. That's 7 times 4 divided by 2, 28 divided by 2, that is 14. So there would be 14 there. And then if I do 8, because I'm just going to use the formula now, if that's okay, equals 8 times 5 divided by 2, that's going to give me 20. Boom, that's it. That is a strange relationship, but that is the relationship between the number of sides and the number of diagonals. All right, let's keep going. Find the angles of rotation that will carry the 12-sided polygon below onto itself. Okay, so that means they want to know if I have a center, right? So I'm going to get this center right here. If I have this diagonal right here, and the diagonal has to go through the center, and then I have this diagonal right here, and again, notice how it goes through the center. Boom. What I'm looking for is that degree of rotation. That's what I'm looking for. So this is very similar to the problems we did before. I just take 360, a full circle, and divide it by the 12 different pieces of pi that make up that 12-sided polygon. And that's going to give me 30 degrees. That is done. What are the angles of rotation? Oh, find all the angles. Okay, oof, there's a lot more than that. Okay, notice every multiple of 30 degrees is going to get me back. So 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees, 210 degrees, 240 degrees, 270 degrees, 300 degrees, 330 degrees, and that's it, because we don't do 360, because 360 would get us back to the original. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different angles that I can rotate this, and it'll make that 12-sided polygon appear to be the exact same shape. All right? So that is your answer. I should have read the question better. Okay, what are the angles of rotation for a 20-gon? Oh my. What are the angles of rotation? Okay, so I'm going to take 360 divided by 20. Is that 18 degrees? It is 18 degrees. Wow, there's going to be a lot of them here. Okay, so 18, double that, 36. Add 18 to that, 54. Add 18 to that, 72. Add 18 to that, 90. Add 18 to that, 108. Add 18 to that, 126. Add 18 to that, 144. Add 18 to that, 162. Add 18 to that, 180. Add 18 to that, 198. Add 18 to that, 216. Add 18 to that, 234. Add 18 to that, 252. Add 18 to that, 270. add 18 to that, 288, add 18 to that, 306, add 18 to that, 324, add 18 to that, 342, and then if I add 18 to that, I get 360, so I'm done. As soon as I get to 360, I'm done. Woo, that was a lot. Okay, so every 18 degrees I rotate will get me back to the original shape. So there's a lot of ways I can rotate it and get back. Okay, moving on. Oh, hold on. We might not have been done with that. We might not have been done with that. They might have asked us for more. How many lines of symmetry? Okay, well, we know from a previous that the line of symmetries match the number of sides. So because it's 20-sided, there are 20 lines of symmetry. Remember, lines of symmetry, there are exactly the same amount of lines of symmetry as there are sides to the polygon. Okay, now we're ready to move on. Number 8, what are the angles of rotation of 15 gone? Okay, 360 divided by 15. Well, that's going to give me 24 degrees. Okay, so here's another way to do it, and I actually like this way. Because when I did it in my head last time, I got a headache. Okay, so the first one is 24. Add 24 to that, 48. So 48 plus 24, 72. 72 plus 24, 96. 96 plus 24, 120. 120 plus 24, I know that one, 144. 144 plus 24, 168, plus 24, 192, plus 24, 216, plus 24, 240, plus 24, 264, plus 24, 288, plus 24, 312, plus 24, 336. And notice if I add 24 to that, I get 360. And that's how you know you're right and you're done, because you should always get to 360 when you keep going. But we don't include 360 because 360 would be the original shape. Because if you turn something 360 degrees, it just gets back to its original. How many lines of symmetry? 15. All right, a regular polygon has rotational symmetry for an angle of 18 degrees. How many sides does it have? Well, if you just take the number of degrees in a full circle and divide it by the rotational symmetry, that'll tell you. 20 sides. That was a problem we did earlier. Right? That was basically problem 7. 20-sided, 18 degrees. But we went backwards. Okay. Our regular... okay, hold on. We're not done. How many sides does it have? 20 sides. Okay, sorry. Regular polygon has rotational symmetry for an angle of 20 degrees. How many sides does it have? So you take 360 divided by 20, and that's going to give you 18. So it's an 18 sides. How many lines of symmetry does that have? 18 lines of symmetry. Because the number of sides and the number of lines of symmetry, they match. Woo! Okay, let's go. Now we're on the go. That was the ready. Let's reflect this thing over. We're going to reflect it over the line of reflection. I'm going to grab a piece of patty paper so I can do that. When I flip over a line of reflection, I mark the top and the bottom of the line, and then I mark my value, my anchor point. And I love reflections over a line because to me they're the easiest thing. I literally just pick it up, turn it over, line up the ends of the lines with the ones I drew. Notice how that landed right there. boom, A prime. I'm done. All right, that's good work. All right, moving on. Reflect point A over the line of reflection and label it A prime. All right. I'm going to do it again. I'm going to mark my endpoint, mark my endpoint. I'm going to give a little direction for that line. Mark that anchor point, flip it over. There's that anchor point right there, and that is A prime. Woo, let's go. Reflect triangle ABC over the line of reflection and label the image A prime, B prime, C prime. Okay. Same thing, even though there's more points, it's still the same process. So I make those. I now draw my anchor points. Those are the vertices. I'm reflecting, so I pick it up and over, line those up perfectly, and then if you color those in again, they'll pop there. Okay, now you got to figure out what is what, right? So this went like this. So this is B prime, whoosh. This is C prime, whoosh. This is A prime. Don't forget to connect those vertices and make those sides. All right, that's done. I like that. Oh, that looks like a parallelogram. Parallelogram, let's do it. Same thing. So I'm going to go boom. Parallelogram is a quadrilateral. There's 4 sides. All right, opposite sides are parallel. So that's what a parallelogram means. Get those anchor points. Now, if you wanted, you can call that B, A, C, and D. And that way, when you flip it, you won't have to guess which is A prime, B prime, C prime, and D prime, and all that fun stuff, because it'll be marked. Flip it. Right there. And then boom, 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 boom. Notice that's A, B, C, D. So A, B, C, and D. Connect them. Whoosh. Done. Money. Given triangle XYZ and its image XYZ prime, draw the line of reflection that was used. Oh. Okay. So we have to draw the line of reflection. To draw the line of reflection, I'm going to go ahead and I'm going to connect those. Now the midpoint is where it's going to go through. So that is right there. Notice the slope, down 3, over 3. So the slope of that is -1. So the slope of a perpendicular is 1. So from there I'm going to go up 1, over 1, up 1, over 1, up 1, over 1. Draw that line. And that is my line of reflection. They didn't want me to actually calculate it. They just want me to draw it. And so that's it. Notice how that creates a 90-degree angle, that right angle right there. Woo! That's beautiful. Okay, let's do it again. So I'm going to draw T to T prime. Okay. I'm going to now find the midpoint. 1, 2, 3, 4. So right there is the midpoint. Okay, this one is money. Right? Because the slope of that is 0. So the slope of the line of symmetry is going to be undefined because the reciprocal of 0 is undefined. That is a vertical line. So that is your line of symmetry. That one was money. That one was easier than that one, actually. All right, there's your line of symmetry. Woo! By the way, that line of symmetry is y equals -1 because y equals -1 everywhere on that line. Is that it? Oh, man. That was good stuff, Maynard. Woo! I'm so happy. I'm going to draw a picture myself. Woo! Yes. All right, you guys have a great day. Enjoy it. Nice job. I'm proud of you. Stay strong and communicate with your teachers. Bye-bye now.